Hi everyone, in this video we are on page 10 of the note packet, and on example 3 we're going to be doing kind of a catch and release on this problem. So first, notice on this one we want to find g prime of x, so an equation for the slope of the tangent line, if g of x is a quadratic, 2x squared minus 3x plus 1. So first folks, we're going to start with the definition of the derivative in terms of limits. So the limit definition for the derivative. So it's g prime of x, so we're using a different variable here, but still a function notation, equals the limit as, see if you can determine the part that goes below the limit, as h approaches 0. So as we close in on the distance between those 2 points, h approaching 0, again, sometimes students will put x approaching 0, so make sure it's that hair beyond distance that is approaching 0. Next, g of x plus h, the hair beyond point goes first, then minus g of x. So the y value of the hair beyond point, the y value of the tangent point, all over x plus h minus x, or just h. So remember folks, really work on getting this memorized as you work through the problems in the practice set. So see if you can do it without looking as you start to go through those. I'd like you folks to pause the video and see if you can do the next step of the work. What is g of x plus h, and what is g of x? And remember, you can use that minus sign as kind of an anchor point for your work. So pause the video and you can unpause it when you're ready to see the walkthrough. So for our first step, we're going to have 2x squared. What are we going to put in for that x? Y, x plus h. Same with that x as well. So 2 places to plug in that x plus h on this one. So 2 times x plus h squared minus 3 times x plus h plus 1 minus parentheses. Don't forget your parentheses there. 2x squared minus 3x plus 1. So there's g of x plus h, there's g of x, there's my subtraction sign, kind of my anchor point between the two, and make sure you've got that g of x part enclosed in parentheses so that I can distribute the negative to everybody. So now we're ready to start simplifying. So x plus h times x plus h, and remember folks, when you have a xh plus another xh, you have 2 xh's. And anytime you drop down to the next line, you're going to have to include that limit notation. So in calc, they make you do it after every step of the work, but here we are just going to do it every time we drop to a new line. So the limit as h approaches 0 of 2 times that FOILed stuff would be x squared plus 2xh plus h squared. And then distributing that negative 3 to the x and to the h, negative 3x minus 3h plus 1. So that gives me a more simplified version of g of x plus h. Then we've got the minus sign distributed inside that parenthesis to be negative 2x squared plus 3x minus 1 all over h. And from here, we're going to do just more simplifying and hopefully crossing off some like terms. Because remember, folks, after you have simplified the top of this fraction, you shouldn't have anything left that you can't take an h out of. So that's why direct substitution, factoring and canceling ends up working for this one, is you should be able to take an h out of everything that's left on the top. So goodbye negative 3x and positive 3x, goodbye positive 1 and negative 1, and hopefully this negative 2x squared will cancel out with something from over here. So distributing that 2 in, we get 2x squared plus 4xh plus 2h squared, and then we've got our minus 3h, and then minus 2x squared. All over h. And ta-da! 2x squared and negative 2x squared cancel each other out, and I am indeed left with an expression that I can factor an h out of everybody. So again, folks, you don't have to take a GCF out, which we wouldn't be able to on this one because of that 3, but you only need to worry about taking the x out so that you can, the h out so that you can factor and cancel. So the limit as h approaches 0 of taking that h out, we're going to have 4x plus 2h minus 3 all over h. And once I am able to do that factor and cancel, then we can do direct substitution, plugging 0 in for that h. And remember, folks, after you do direct substitution, instead of using just a standard equal sign, I like to do the equals arrow to show that I am no longer evaluating the limit. Once I plug in that 0, the limit aspect of this problem is done, and I'm left with 2 times 0. Oop, and I should have put that 4x first. Let's go ahead and do that. Sorry, 4x, and then plus 2 times 0 minus 3. So 4x minus 3, and that is as simplified as we can go. So g prime of x is equal to 4x minus 3. Now remember, folks, what did we just find here? This is the equation that describes the slope of the tangent at any given point. So it's not that the slope of the tangent is 4. It's not that, hey, I've got a line that describes the tangent line. I've got a linear equation that describes the slope of the tangent line. So this describes the slope of the tangent line at any given tangent point x value. So if I want to find g prime of -2, we want to find the slope of the tangent at -2. And folks, I'm just going to go back to the calculator here just because I do think it is kind of nice to be able to see visually what this looks like. So we've got our 2x squared minus 3x plus 1, zoom standard. Dum-de-dum-de-dum. There's our quadratic. So if I want to find g prime of -2, if I go to trace and do -2, my tangent point is all the way up at 15. So I'm going to go ahead and change my y max to 20. Then if I do trace of -2, there is my tangent point. So if I were to draw a line that only touches on that point on my function, what can we tell about the slope? We can tell that it's going down and to the right. So down and to the right, so it would be negative, and that it is fairly steep. So let's see what happens when we plug -2 into our derivative to find out what the exact slope of the tangent would be at that point. So equals 4 times -2. Plugging that in for the x. Minus 3, that gives me -8 minus 3, or -11. Does that seem like a legit slope for that tangent line that we imagined drawing at -215? If I were to draw in that line, yes, it would look like it has a slope of -12. So that is the slope of the tangent line. And if I wanted to find the equation of that tangent line, I could use point slope form and use -215 as my point and -11 as my slope. So this is not a coordinate. It's not -2, -11. It says that this tangent point x value yields a tangent line slope of -11. So the actual tangent point is -215. And again, I use the trace button on my calc graph to see what value corresponds to -2 on my actual function. That input, that x value of the tangent point, gives me that output in my derivative, which yields the tangent line slope. So again, folks, understanding the pieces of this is very important because it is easy to get confused because it's like, well, this is a linear equation, so is the slope of that 4. This represents the slope of the tangent at any given x value for the tangent point. So I would take some time to study these definitions and make sure you understand all the working pieces. So pausing the video, I would go ahead and try to find g prime of 0. So plugging 0 in for x, we would get 4 times 0 minus 3. So g prime of 0 equals negative 3. Does this seem legit with our calculator? Well, first, where is the tangent point? So at what y value do we have 0 for an x value? There we go, right there at 0, 1. So our tangent point is 0, 1. And if I draw a line just touching on that tangent point, it says that tangent line would have a slope of negative 3. Seems legit with what our graph is saying. So folks, hopefully this gives you a better understanding of how the derivative works and how the limit definition of the derivative helps us find a generalized equation that gives us the slope of the tangent line. And that concludes page 10 of the notes.